So the third type of problem that we're going to see apply the sum and difference identity is when we're given one of our special angle ratios in an unknown angle x. So that angle x, the way we're given it here is we have no way to define angle x. Okay, so we're just going to have to leave that as an unknown quantity. The 3 pi over 2 we do know. But the first thing is, when I see that minus inside the cosine, I have to go straight to my identity. So I'm going to have my identity. So my identity is going to be cosine. For cosine, it's going to be cosine of 3 pi over 2, cosine of x. Since it's a minus in between, the cosine formula uses a plus. Then I end up with sine of 3 pi over 2, and then sine of x. Now the only part of this that we can define is a 3 pi over 2. And 3 pi over 2 is going to look like this in the circle. The x is an unknown quantity, so we have to leave it as cos x and sine x. But what ends up happening is we're going to be able to simplify this expression because we can replace cosine 3 pi over 2. The cosine value of 3 pi over 2 is 0. So we end up with 0 times cos x. Well, that means that this whole expression is equal to 0. Sine 3 pi over 2 in that circle is going to be negative 1. It's going down. And then we end up with sine x. Okay, and again, sine x has never been defined. X has not been defined, so we have to leave it as an unknown. But this just ends up being negative sine x. So what ends up happening is this simplifies to negative sine x. So this is an identity. So for any angle x, cosine 3 pi over 2 minus x is always going to be equal to the negative sine value of x. So we can do similar problems with 90-degree rotations. Now we did problems like this without a formula, but now we're going to use this as a formula. So in the past, we did a problem where we saw that sine of theta plus pi over 2. So if we did a horizontal shift of pi over 2 to the left, the sine graph becomes the cosine graph. So this is an identity. And we can show this identity. We've shown this before in that if I have angle x, which I've drawn in red, okay, so there's my angle x. Okay, I'll maybe highlight that as well. My angle x is in red. The cosine of that angle is going to be this length right here. Now notice that that same length shows up in the blue angle when I add 90 degrees. That same length shows up in the vertical. Well, that blue position really is really x plus pi over 2, or x plus 90 degrees. And that green length, the vertical length, is vertical is sine. So the sine of the position x plus 90 degrees, that vertical position is equal to the cosine of x, the horizontal position of x. And this is an identity. Okay, we've seen this before in other ways. Now this can be a little bit hard to do. We can think of this graphically as a transformation shift. We can think of this as a rotation in the circle. But we could also do this as an identity. So we can use our sum identity to prove this same identity. So since there's a plus in there, what I'm going to do is I'm going to use my sine identity for plus. So sine x cosine pi over 2 plus sine of pi over 2 cosine x. That's my identity. And that's going to be equal to, on the right-hand side, cosine x. Well, I can work out cosine of pi over 2. Cosine of pi over 2 is going to be 0. So I end up with sine x times 0, which works out to be 0. Over the right-hand side, sine of pi over 2 is 1. times, well, cosine x is unknown, so I'm just going to leave that as cosine x. And what ends up happening is I end up with cosine x on the left-hand side equaling cosine x on the right-hand side. So I've proven this identity. So I can prove this identity using the sine of alpha plus beta formula. But applying the formula, I can show that geometric identity, which I can show in the circle, which I can also describe as a horizontal shift of sine. Okay, so this is probably the easiest way to prove this particular identity, is just to apply the sum and difference formula to it.